We take the Earth and slice it open, we find that it's made out of a bunch of layers. We've got the crust on the very top, then we've got the mantle, and then we've got the outer core, which is liquid, and then we've got the inner core that's solid. But how do we know this? Well, we study the seismic waves that are produced by an earthquake. When an earthquake occurs, it releases two types of waves that we need to know about, P waves and S waves, and they travel through the Earth, and if we study these waves, we can determine the internal structure of the Earth. The first type of seismic wave we're going to look at is P waves. P waves is short for primary waves, and they're called this because they arrive first. So they're the fastest type of seismic waves. And as you can see, the particles in a P wave oscillate along the same direction, in other words, parallel to the direction of energy transfer. So in other words, they're longitudinal waves. And also another thing to keep in mind that's very important about P waves is they can go through both solids and liquids. You can also see they're made from compressions where the ground is compressed together, particles are close together, and rarefactions where the particles are far apart. The second type of seismic waves we're going to look at are called S waves. S waves is short for secondary waves, and they're called this because they're slower than the P waves, so they arrive second. And as you can see, the particles in an S wave are oscillating perpendicular to the direction of energy transfer. In other words, it's a transverse waves. Finally, the important thing to know about S waves is they can't go through liquid. Okay, so when an earthquake occurs, it releases these seismic waves. And imagine you're standing over here with a seismograph, which can measure the vibrations in the ground. If you're standing over here, you'll detect both P waves and S waves because they'll just go through the mantle and they'll reach outside. However, if you're standing over here and you've got your seismograph ready, you will detect P waves because they will go through. However, you will not detect S waves because when the S waves try to go through the outer core, they can't. This is because the outer core is liquid. Okay, to summarize, there is a region on the Earth where you won't be able to detect S waves after a earthquake has occurred, and this is because the S waves can't go through the outer core. They can't go through the outer core because the outer core is liquid. So that's how we determined that the outer core is liquid. Another important information we can get from seismic waves is how they change direction. This is refraction. This is them changing direction because they're changing speed, and that's because the different layers have different densities. So they also change direction, that the boundary between different layers of the Earth. You can see here. So when we have seismographs set up across the world, some of them don't even detect P waves, even though the P waves can go through the outer core and the liquid in the outer core. So this information can be used to determine the density of the different layers. To summarize, waves travel at different speeds in different layers, and this is because the different layers have different densities and they have a different state of matter. So at the boundary between these layers, there's also a lot of refraction going on. There's a change in direction. If we put all this information into a computer and we do some calculations, we can determine that the outer core is liquid and that the inner core is actually solid.